only synopsis design compiler can recognize such error. And about the tuition itself, compared to proprietary tools, the needs for complex support for system Verilog goes against extensive IP usage. And in general, the logic equivalent check should be performed at the end of each step. But the OpenMPW project just do a checking at the end of the whole process. It is called pre-check. But design compiler will report RTOS errors such as mismatch or signal width. But users will keep running and output an incorrect network without any notification. That sounds a little dangerous. Also, the ECO stage is still ongoing. Multi-thread acceleration only exists in detail routing. Despite more up-to-date algorithms should be added to this flow, online user guide is general in proprietary tools, but OpenRoad doesn't have it. Okay, here comes the performance part. We used users and ABC versus Genius respectively in logic synthesis. We synthesized real 1 with 8 SRAM macro running at 80 MHz. Users performed 4 kinds of strategies corresponding to error and delay optimization, and we use the default setting of Genius. Users doesn't do cloud checking at all, but Genius does. I plotted this data as histogram. Let's see the first 3 images. For the same design, the proprietary tool can provide netlists with smaller error, less gate count, and lower leakage power. Maybe its closed source algorithm contributes a lot to circuit simplification, and propagating is an effective way to save power. But surprisingly, there are 3 synthesis strategies of users bring about faster synthesis solutions. And for the timing, the delay driving optimization in users is very effective. Even we can get time convergent networks without any additional adjustment. For the physics implementation, we utilize OpenRoad and Novus respectively, both input netlists generated by users for fairness. And we had a green rail with 1 core and did routing with 8 cores. We found that OpenRoad cannot fit all cells over 50% core utilization. If so, higher cell density will lead to routing congestions, but Innovus can make it and generate smaller layouts. Besides, proprietary tool can achieve 65% of the wireless of the open ones. Although the runtime of Open2 is inferior to that of Innovus, but it has potential in multi-thread acceleration. So let's look into the detail of runtime. OpenRoad spends most of its time in routing, but Innovus puts more effort in placement. Maybe the later one sounds more reasonable, because in general, a scientific placement can lead to either routing congestions, can lead to either routing convergence. For the time allocation of OpenRoad, detailed routing is the most time-consuming task. We noticed that the open router in OpenRoad Triton route has not been updated over 2 years. That may be a little out of date. Besides, the placement engine in OpenRoad is replaced. Recently, we have also seen so many published algorithms have defeated. So maybe we can try to integrate them into OpenRoad in the future. We also found users cannot generate netlists with correct hierarchical information. Even it already has an option called hierarchy. Somehow, it will ignore some module with macros, or you need to harden one module first, then harden another. Using such netlists without hierarchy can lead to confusion when visualizing the final layout. We don't know what happened in this cell growth. And as you can see, OpenRoad and Novus do macro placement differently. If we use the netlist generated by design compiler, we can get to know the detail of different modules by Innovus design browser. The process of hardening granular has reduced the conversion difficulty in the open chip flow. So we are trying to bring about higher quality solutions. For better error, timing, and shorter wireless, we have optimized Bluetooth, a machine learning-based decision-making framework to OpenRoad for business optimization. And for better user experience, we gathered a comprehensive list of user problems that arise during program execution, and we built a solution-inspiring error system, giving solution hints when the program encounters errors. We won the Excellent Effort Reward in the OpenRoad 7-nanometer contest for these two contributions. The RISC-V and open source ecosystem reduce the barrier to the silicon world. Design and fabrication